Hey everybody, today we're going to go over your assignment. There are two different parts to this assignment. There is the classifying numbers part, as well as the number property part. And I guess in the middle, we talk a little bit about finite or infinite, so you could call that its own separate part here. So let's get started here. Let's look at this table below. Place an X in any column that applies. So the first number that we have to classify here is radical 31. So this is where you would have to ask yourself what the square root of 31 is. And I don't know. I know it's between 5 and 6. I know it's a little bit bigger than 5.5. It's going to be a little bit closer to 6, but I don't know exactly what it is. And anytime you have a square root that doesn't work out perfectly, it is automatically irrational every single time. Now, it's also real because they're all real. In fact, we could just sort of, put in the x's right here and just get that over with. All right, looks good to me. Now, the next example is 31.3. But in this case, we have a line over the 3. That means it is a repeating decimal. Now, sometimes the first instinct is to say, hey, well, it's going to go on forever, so that must make it irrational. But the truth is, anytime you can write a number as a fraction, it counts as rational, whether that decimal repeats or not. Now, in this case, you might not have necessarily known this right off the bat, but if you were to take 94 over 3, and you were to punch it into a calculator, you know what you would get? Yep, 31.333333. So even though the decimal goes on forever, it still is technically rational because it originally came from a fraction. So the best thing to remember here is any repeated decimal is rational. Every time, no matter what, it's a guarantee. All right, we saved the easiest one for last. 31. Yeah, okay, 31. Natural, got it. Whole, got it. Integer, yep. Rational, well, yeah, 31 over 1. Whoop-de-doo, there you go. And that takes care of that first section right there. All right, let's move on to this finite and infinite stuff here. Is the set of all whole numbers less than 10 finite or infinite? So the question is, would you stop or would you go on forever if you had to name them? So let's take a look at the whole numbers less than 10. Let's see, we've got 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Hey, guess what? I stopped. So it's finite. All right, what about greater than 10? That means 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm getting sick of it already. Yeah, it's definitely infinite. If I had to keep listing those numbers, I would do it for the rest of my life. All right, let's take a look at number 4. 7, 8, 9, 10, 11, 12. Is that finite or infinite? Well, you see that dot, dot, dot at the end. That's basically telling me I'm going to do this forever. So we're going to call that infinite. Now, number 5, you can see the dot, dot, dot is in the middle. Sometimes people just get lazy. They don't want to list out every single number, so they just say dot, dot, dot. But they put it in the middle. So is there still a starting point? Yes. Is there still a stopping point? Yes. The dot, dot, dot in the middle just meant nobody felt like continuing. Nobody felt like writing the 10 or the 11. But they're still there. Anyway, since it did stop at 12, it started at 7, it stopped at 12. Technically, it is finite. All right, what number property is being demonstrated? Let's go through here and let's be as specific as we can here. This property right here, number 6, is the commutative property of addition. It's good to clarify whether you're dealing with the addition property or the multiplication property when it comes up. Like, for instance, on number 7, you would want to call this the inverse property of multiplication. And it's called the inverse property because you're going in reverse. You've got this number 2 and you're asking yourself, what can I do to cancel it out? What can I do to get rid of it? Well, you multiply it by a half. Half of 2 is 1, so that 2 cancels with that other 2 in the denominator. All right, I think we all know this one. That one doesn't have a classification for it for addition or multiplication. It just is what it is. It's the distributive property. Number 9, now we're talking about keeping a number the same, keeping the number what it is. So this is the identity property of addition. If you were doing the identity property of multiplication, then instead of adding 0, you would multiply by 1, because then you would get to keep the number exactly the same. All right, next, I see grouping symbols. Who you group with is who you associate with. All right, there you go. Associative property of multiplication. And number 11. 15 minus 16 equals 16 minus 15. That's a trick question. It's wrong. That's not true. 15 minus 16 is negative 1. 16 minus 15 is positive 1. The commutative property works for addition. It doesn't work for subtraction. It works for multiplication, but it doesn't work for division. So you have to be really careful with these things. The associative property is exactly the same way. It works for addition, but not for subtraction. It works for multiplication, but it doesn't work for division. So you need to pay attention. All right, that looks like that's all for me. Good luck on your assignment, and have a good day.